Today, we are demonstrating our automated, AI-driven solution for forestry health monitoring. The process begins by importing pre-recorded aerial drone footage, capturing a flight path over a dense forest canopy. Additionally, users can upload their existing tree inventory data to overlay and visualize it directly on the interactive map. As the analysis runs, you can observe the system operating in real time. Whenever the AI detects signs of dieback, it highlights the affected area with a blue bounding box in the bottom left pane, displaying a score that indicates its confidence level. Users can adjust this confidence threshold in the right middle pane, lowering it to maximize potential detections for broader screening, or raising it to ensure higher certainty. Users can review the detection photos within the application at any time by simply clicking the corresponding marker on the map. As the drone continues along its flight path, the camera may capture the same affected tree across multiple frames. To prevent duplicate logs, we introduced a parameter called the K factor in the middle right pane. This acts as a cool-down period between successive detections. Raising the K factor minimizes the chance of logging the same object twice, while lowering it ensures no potential issues are missed during the flight. For this specific use case, we deploy a specialized AI object detection model trained to identify dieback, a critical condition where foliage withers due to disease or environmental stress. Beyond forestry, we can custom-build object detection models to suit your specific operational needs, whether that means identifying vehicles, personnel, wildlife, or early signs of fire and smoke. Whenever an issue is detected, the software maps the drone's coordinates and logs the unhealthy canopy. This lets users narrow down the location of affected trees without spending hours reviewing video footage. Once processing is complete, the software automatically exports all flagged frames into a designated results folder. Opening this folder, we can review the high-resolution images, each featuring precise latitude and longitude coordinates embedded directly within the file's metadata. Each saved file provides a clear, labeled snapshot of the diagnosed tree canopy, ready for forestry teams to investigate on the ground. Thank you for watching.